Hello everyone, Mandar here from Flentas Technologies. Thanks everyone for joining the webinar. I'm just waiting for one more minute so everyone can join. Meanwhile, I will introduce myself and introduce the company. So, we are born in the cloud consulting company. We are advanced consulting partner with AWS, and we are the first AWS IoT competency partner in India and Middle East. So we have helped multiple companies and multiple industries. We have more than 100 customers, specifically focused in fintech, manufacturing, and gaming industry. Today we are completely going to focus on industrial IoT and how can we enable multiple organizations to adopt IoT and embrace Industry 4.0. Before jumping onto the topic, I would like to give you some figures, some facts before we discuss in detail about the topic. So if you see the screen, uh, as of now, in 2020, we have around 30 billion connected devices, which is fairly 3 to 4 times of entire human population, which is around 7.5 or 8 billion. But if you go a little further, right, in 2025, the projected connected devices are around 75 billion, which is fairly 10 times of human population. So it sounds like every human will have 10 devices which is connected to internet. But is it true? No, right? So how so many devices will come and connect to the internet? All these devices would be coming from industrial IoT. So entire world is moving toward IoT. So organizations should ask, are they moving? Are they ready for this change? And that's the reason IoT is one of the major part in Industry 4.0. So if you see, I will just go little back in the history where we started the first industrial revolution, Industry 1.0. What happened then that human invented the water power and steam power, which gave birth to the machines. So entire production system moved from handmade to machine made. And the first revolution started there. And today we are at Industry 4.0, and IoT is a very huge part of the fourth industrial revolution. And that's the reason IoT is making a huge business impact. It's not just any technology or any buzzword which will come and go. It's going to impact every industry, and it's going to impact every life. And that's the reason I will little bit deep dive onto what are the benefits of IoT and why should we embrace Industry 4.0. So if you see, IoT has multiple benefits. The major benefit which is coming out of IoT, it's seeking successful business outcome. It's going to impact on the business directly rather than just a technology, right? So you can do a lot of remote monitoring. You can do a lot of big data, AI, ML. You will able to improve the operational efficiency, improve the quality. But all these benefits at the end will fall in two aspects. And I would be focusing on those two distinct aspects. So one is revenue growth, and second is operational efficiency. So how do you think a technology which will directly impact revenue growth for any industry? So I will give you a few examples where we can see how it will impact directly to the revenue growth. First, prioritizing features which are most important to consumers. So which will help you to monetize those features early. So you will get the insight what consumer wants and you can release those specific things to the consumer. Then data can turn into insight which will pave the way for new products and markets. Help you to get that added revenue. Second, the manufacturers who are only selling the products can also sell the services with the help of predictive maintenance. So you would be more confident while selling AMC. It will have entire framework. It will have a data to back that how you are going to drive the entire maintenance cycles. And cameras can give you the first hand customer reaction to specific promotional activity. So you will get to know that how your customers are reacting to any promotional activity. For example, in the malls or in the retail outlets, you would able to catch the reaction of your end customer rather than just bumping a promotional activities to various consumer. So this is on the revenue side. I will talk a little bit about operational efficiency now. How operational efficiency and how IoT will help us to get there. So IoT basically will help to reduce the overheads. It will help to optimize the supply chain, and if you use it correctly, it will provide valuable information. So predictive maintenance can save a significant amount of cost or traditional maintenance activity, because you will able to understand when your machine will break out or when your assembly lines will need a maintenance, and you can plan things accordingly rather than reacting to that maintenance or reacting to that situation. So you would be able to optimize your supply chain with help of solutions like asset tracking, and there are multiple other ways which will directly impact on operational efficiency. So these are the two distinct things which will come out of any industrial IoT project, and it will give one of this direct impact on your business. Now I have spoken a little bit about benefit. I would tell you about our approach, how we look at towards the industrial IoT. So IoT is basically Internet of Things. So we have things in place. So every company have a manufacturing plants, factories, devices, equipments. So we have that first thing sorted. We already have the devices. Moving to second thing is the connectivity. Once we connect these devices to the internet, the moment we can start getting the data, we can retain the data, we can extract the data. But we need to control this connectivity. We need to secure the connectivity. That's the reason connectivity and control will come into the picture. And once we have this data, the next obvious stage that we will do the big data analysis, we will do the AI/ML on top of this data. We will get some meaningful insights out of it, and we can use those insights for multiple things. And one of it that it will again go back to device. You will again make changes in your device to make those device better. And that's the reason I have kept it circular and not a pyramid. So this cycle will continue. You will improve the device, it will have a better connectivity, it will have a better analytics. You might be again improve some specific sensors in the device, you will get a specific new data, and again you will able to improve analytics, and it will give you the better prospects over the entire manufacturing plant or factory or equipment wherever we have connected. So whenever I talk to any industrial production manager or the plant manager, they have a very strong case that we already have a SCADA, we already have a PLCs, we can write logics, we can give the commands. Then why do we need a industrial IoT? We can do most of the things. So why do you think, where do you see IoT will fit, right? And that's the reason I have kept this site specifically. So don't take it as a comparison. I just want to give you the perspective that IoT is going to sit on top of this ecosystem. It's not going to disrupt this ecosystem. So I will just give you some comparison that how IoT will enable all these devices to do a better job. For example, scalability, right? IoT is specifically made for a scale. If you have 100 of plants across country or across continent, right? You can process huge amount of data with the help of IoT, which is a limitation in traditional SCADA devices, because those are scattered across multiple plants and not in a single plant. Where IoT is this kind of umbrella which can cover most of the things. Then comes your big data, right? Again, if you want to churn huge amount of data, say for example petabytes of data, right? How will you able to do it with scattered SCADA devices, right? That's where again IoT will come into the picture. It will help you to retain long-term data. It will help you to do the lot of analysis on top of data, and then you can do some historical analytics to understand how my plant perform in say last 5 years. Next is standardization. Again, IoT is a very new technology. So it's designed to be a standardized. So your data ingestion, aggregation, and retention, all this could be standardized across the plants. So it will help you to add or multiply whenever you are doing any changes in the technologies. Interoperability. Again, there are many SCADA devices with many version, many manufacturers. It's difficult to interact with each other, right? Again, we have to put a lot of efforts to do that. But in IoT, we have protocols like MQTT, which enables platform to communicate with each other. You can give the bi-directional communication, and you can do a lot of things if you have interoperability in place for all your IoT implementations. AIML, right? AIML is making a lot of noise in all the industry, right? And IoT will basically enable you to adopt AIML once you have a data, right? Because AIML will need a lot of data to create those specific models. For example, you have a plant which have say 3 different assembly lines. You can connect those with the industrial IoT, and you can create 3 different and distinct AIML models to understand insights about each assembly line, which is different, right? If it's the same, we can have a single model. And then it will give you a various insights like predictive maintenance, repair, replacement. So before any breakdown, you will have idea that what I need to do with my assembly lines. You would able to take action. So production manager or plant manager sitting in the cabin would able to make some decision without sitting on the floor every time, on the ground every time. And last one, I have kept the cost, I think, which is most dear ones to all the industries, right? So people think that IoT or adopting IoT is going to be a huge expense. Of course, it would be expense, but it will not be a huge expense. How that we can adopt IoT with the help of a lot of cloud services. So cloud will enable you to do a lot of things. So data ingestion would be made very easy if you're using it over the cloud. Storage would be very easy. Processing that huge amount of data would be very easy and cost efficient if you do it on the cloud. And we can bring that connectivity from your devices to the cloud with the help of IoT. So the entire gamut can be played with the help of industrial IoT. So this is just a high level overview. This may not be the exact impression from the industry. We'd love to interact more on what are your opinions on this. I will talk a little bit of use cases with specific industries. So you will make it sense if it, what is happening in your industry and how you can relate it. So heavy industries, right? So the equipments are very expensive. So predict the lifetime of equipment is very critical when we talk about the heavy industry. So that's where we can do the trade-off of replacing the machine versus repairing the machine. And we can do that trade-off with the help of IoT. So we will able to understand beforehand that this is not the time to replace, this is time to repair. And you can save a lot of cost before jumping onto any decision. So you will have a facts and insights to make those decisions. Next is the chemical industry. So chemical industry is completely a process driven industry, right? And it has a lot of different processes which need to be efficient. So with the help of IoT, we can make sure that those processes, those factors are very efficient and monitored correctly. And we can simulate that entire process. So we can try out new things. And that's the reason simulation gives an added advantage if you are in this kind of industries. So rather than doing it actually, you can do it simulation, and then you can find out the result. And when you see my results are getting accurate, you can actually try it out that process. So it will save you a huge amount of cost and time. Third is pharmaceuticals, right? Now everyone know what has happened in the world due to COVID-19, right? This pandemic has put world in the standstill. Everyone is working from home, and every pharma company is in the race to find out, to invent the drug against COVID-19. But that cycle is very long. It's not that easy. It's a very stringent process. So they can shorter the market launch, right? With the help of this kind of technology, you can identify which factors are impacting the result, and then you can tweak those factors rather than every time doing those processes. So you can get a lot of insights if you are equipped with the IoT. You don't need to go deep dive every time. You will have all those things on your dashboards. Fourth, I've kept insurance industry because it's one of my favorite. How industrial IoT will impact something in financial services, right? So currently, everyone is charging a vehicle premium as per your car. So if you have car is say 1500 cc, they have standard premiums which everyone pays, right? But what is happening now in the industry? It's a reality. I'm not just giving a hypothetical situation that they put industrial IoT device in your vehicle, which will track your driving patterns, the way you maintain the vehicle, in which terrain you drive your vehicle, and according to that they charge your premium. For example, if I am a rash driver, okay, I should be paying higher premium. But if my colleague Shohel is a good driver, why should he pay the same premium as I am, right? So this will bring out a lot of such innovative use cases going forward as well. And food and beverages, because country of 130 crore people, food is basic for everyone, right? So we can prevent adulteration in the food with the help of IoT. We can provide instant alert across a network to enable rapid response if we find something like a contamination in the food. So we can control the food supply chain. For example, for foods like ice cream or specific food which need a cold storage. So we can control that entire supply chain with the help of industrial IoT, right? I will just give one use case where we help one of our customer, and then I will hand it over to Shoel for more deep dive onto the technology. So we had a customer called as Spartans Engineering. It's a hoist manufacturer. So they provide hoist to various construction site. Okay. So hoist, if you see, it helps to transfer the material from ground floor to any floor. You must have seen it in multiple construction site. Okay. So what we help them? So we help them to do the remote monitoring of that device. So they can see number of time lift is running. Is it serviced properly? What kind of load they are carrying? Is it as per the best practices? So they can do all this thing remotely, and it will help them to do the operations and management. So we are also tracking sensor which give you the flag if your warranty is no more void. So if you are not maintaining it properly, that sensor will give you the red flag, and then owner will not be responsible to give the warranty for that system. Another interesting use case we did here, that his machines are scattered across India, right? So to make sure that he track his asset, we also keep the GPS geo tracking. So we can you can stop the misuse of the movement of that hoist. And last, one of the interesting use case, what we did, that his customer never used to pay him in the time. Okay. I think we all face the same challenge in the industry, right? And he's helpless because his devices are scattered across India. So what we did, we basically enable him to switch on and switch off that hoist remotely. So if someone is not paying, he can switch it off. And once he get the payment or assurance, he can switch it on. And so this kind of use cases will come up. So it's a journey, what I feel. And I think the more we continue with the customer, the more use cases will come out from this technology and this kind of implementation. So I shared you info regarding more of a why you should adopt IoT, why you should embrace Industry 4.0, and what all things are possible in this technology. Now, my colleague Shohel will talk more about how of the technology and what all technologies will impact while implementing industrial IoT. Thank you everyone for joining the webinar and being patient. Shohel, over to you. Yeah, Shoel, you are not audible. Can you unmute the? Hello, guys. Do you hear me? Am I audible to everyone? Yeah, just say yes if I'm audible. So I will just check with Shohel.
Hey,
Yes, Shohel,
hi,
you're
am I
audible
audible?
now. I will just go on the mute so you can continue.
Great. Sorry, guys. There has been a problem with the broadband. Great. Uh, yeah. So I will just hope you're able to see the screen as well. I will change the slide. Yes. Uh, yeah, so I will be covering the solution architecture. If you are embarking on an IoT journey, if you guys are if you guys are planning to implement an IoT solution for your own organization, we have tried to put forward a typical architecture that every organization should follow, or is the best practice that we have seen with our past customers. The first and foremost, on the very left, you will see data sources. So data sources can be anything. It can be a PLC device, it can be a historian, it can be a SCADA, it can be a sensor. You can fetch data from any and every kind of device. Data sensing, we have a gateway. So once we have figured out the sources of the data, we will always look at what are the different ways in which we can fetch this data from these devices. So normally people use gateways. There are a lot of gateways available on the market. But the important thing here is to understand a gateway which can interact with your industrial protocol. So we have seen multiple protocols like OPC, there is Modbus, there is Profinet, Profibus. Depends on the protocol. There might be a need to tweak a little bit on the hardware, or maybe buy a translator hardware which can talk in those proprietary protocols. So the gateway is very important piece. After the gateway, once the data is there in the gateway, you will always want to connect this gateway to the internet, to the cloud, where again an important piece. I'll actually break this architecture down into individual components, and I'll try to make you understand how that piece is important. Once the data is there on the cloud, it can be used in variety of ways. The first and foremost is you can just put the data in our operational data store, where you can just connect it to some application which is web facing, and you can have pretty much any kind of custom dashboards built on top of it, and you can serve it to your mobile clients or web clients. The other way to do it is you can some organizations have a practice of forming a data lake. So you can also push your data directly to data lake, and which is S3 in AWS's case. So data lake essentially, I'm not sure how many of you are aware, but data lake is something where you just keep on dumping all your enterprise data. It can be IoT data and your ERP data and your business data. Anything, any data can be dumped in that storage, so that you are able to then mix and match, correlate, slice and dice data with the data that you're getting from your IoT devices, and interrelate it with the processes of your organization or the ERP data that you have. Right? It will help you draw more insights out of your data. More operational and actionable insights can be drawn if you mix and match IoT data with your enterprise data. Right? So there are of course a lot of tools available in the ETL. So analytics is one piece where you basically try to derive insights from the data. There is another, the last one, right, which is machine learning and AI, where you try to predict the data. This is very important for IoT use cases, and is a driving factor, which is triggering a lot of IoT use cases to be adopted by the industry, because it comes with promise of predicting the maintenances, right? If your devices are going to fail, if there is some not even devices, if there is something that you want to predict, AI and ML is something that people always look at. Like Mandar said, there are a lot of industry uses coming around machine learning, and we will also talk about those cases down the line, with more detailed explanation of each component. I hope this architecture is clear. I will just try to get deep into the considerations of each and every component that I just mentioned, and try to explain what all considerations you should really look after or focus, or maybe put in your prerequisite checklist to before going ahead with that particular component in your IoT adoption journey, right? Yeah, so the first one is gateway, right? So now the gateway can, so the definition of gateway is very subjective. You can have the sensor itself as the gateway, where you are directly pumping data from the sensors to the cloud, and that is how your business case might permit, right? There are other use cases where there are multiple devices attached to the sensors, and you have a hub and spoke model where you have multiple sensors attached to a single device, single gateway, and that gateway is facilitating the transmission to the cloud. So this is how the deployment topology, what deployment topology is, right? And you should really understand how. So the next one is protocols and connectivity. So by protocols, I already mentioned, right? There are industrial protocols that your sensors are emitting the data in, and your gateway is basically interfacing with those protocols. This is one way to look at it. The other way is how do you really connect the sensors to a gateway. If you have a hub and spoke model, there are wired and wireless communications possible. If you say, for example, you have LoRaWAN, if you have dispersed fields, farms spread across acres and kilometers of land, and you want to get data from there, LoRaWAN is something that you can look at. For home automation use cases, you can look at Zigbee, right? So Zigbee is something which allows you a mesh network in a radius of around 1 to 2 kilometers or below that. There are other transmission wireless protocols available, which is like BLE. So Bluetooth is nowadays used by a lot of companies, and for a lot of use cases, because it has been enhanced to sustain long ranges. Thirdly, there is edge processing. So whenever you are trying to figure out what gateway you should use, edge processing is something that you should understand. If your use case demands edge processing, whether if you're going with a microcontroller, edge processing might not be possible, because microcontrollers come with a very constrained CPU and capacity. If you're going with say a microprocessor, or a very good performance gateway, which will provide you edge processing capabilities, that is what you should basically be looking at, right? This is a little consideration that you should make. Power supply, this is very important. Again, this is very much business specific. We have seen time and again with a lot of customers, especially for customers whose gateways or sensors are on the go, right, for asset tracking use cases, for the use case that just Mandar mentioned, for one of the construction site, right? There are though construction sites have those power sources available, but sometimes it's not feasible to provide power supply to new construction sites because the electricity is just not there. So you need to also make sure how you'll be powering your gateway once it is deployed in production. So it's a very important consideration. Second, the last one is environment factors. I think this will affect all the industries. Environment, by environment, I mean to say that you have your IoT devices in indoors, you have IoT devices outdoors. For indoor use cases, I think there is not much that needs to be taken care of. For the outdoor ones, you need ruggedized devices. Some industries specifically, recommend to comply by IEC standards, where you need to have IP65, IP67, 66, enclosures, so that your device is ruggedized and it is able to sustain the extreme weather conditions outside, right? So I think these are the considerations that you should really look at when you are planning to design or implement a gateway. On the right, you will see a couple of services which will help you fast pace this entire process of you building a gateway, right? So first and foremost is free RTOS. So free RTOS, I'm not sure how many of you are aware. So free RTOS is an open source microcontroller library or microcontroller kernel, which basically is supported by a lot of hardware devices, which enables you to basically control and read signals from the sensors and pass it on. So it's a very low power, low capacity, low feature set, constrained kernel, which is used by a lot of microcontrollers. So this AWS free RTOS, why I say AWS free RTOS? So AWS has basically built a lot of libraries which are compatible with free RTOS based microcontrollers, and they basically allow you to integrate very seamlessly with AWS IoT ecosystem if you have a free RTOS based kernel running on your device. The other one is Greengrass. So this is an important one. Greengrass is basically a message is basically a edge processing engine which will provide you pretty much everything that you want to build your own gateway, right? So if you are planning to build your own gateway, you might start off with, okay, say, okay, I will just build some services which will fetch data from the sensors. I'll build my own buffer mechanism. I'll also build my own cloud connectivity. So if you want to really save a lot of time in building your own gateway software, which again has to be very much seriously thought about. AWS Greengrass basically helps you give a drop-in ready-made edge processing service, which will help you provide all these feature set, local buffering, connecting to industrial protocols, and connecting to the cloud. Everything is provided as a de facto feature set in Greengrass. So if you're building a new device gateway or a gateway, I think you should seriously consider Greengrass for the job. I hope that was insightful. I'll move on to the next component. So we have device security. So I think security everybody understands and is very important from IoT perspective. And you might have seen a lot of horror stories out there where IoT devices have been compromised at multiple junctures and at multiple places in the world. So there are a few measures that you should really consider before building your own gateway. So this security slide is basically focusing just on the gateway solution. So I will first cover the physical security. Physical security, as I said earlier, it basically will focus on the devices which will be outdoors, which are not in secure premise or indoors in a factory kind of a location. So for those devices which are outside in the farms and in asset tracking locations, which are just on the go, physical security is important. How do you take care of physical security? So first and foremost, you need to have a very ruggedized enclosure. You need to have some compliant ruggedized enclosure. And how do you track if that physical device has been stolen or is misplaced? Like we have, also like Mandar mentioned in the previous use case, we have tried to implement a GPS, based tracker, which was installed on the device, so that the whenever the device is switched on after it has been misplaced or someone has stolen it, we'll be able to understand whether that device, where that device is after it has been misplaced or it is stolen, right? So this is, I think you can implement geofencing using GPS for physical security. There is device security. So device security, I mean, takes care of multiple. We want to focus on multiple aspects of security on the device, starting from the OS metrics, like there is malware getting installed on your device. There is your device is basically compromised to be a part of a larger DDoS attack, right? You need to take care of that as well. That is a very prevalent thing in IoT. Then you need to also take care of secret keys, right? How do you take care of secret keys? So what is a secret key, for example? I mean, so first of all, so secret keys are basically keys which is a unique identifier for any gateway device, which you will want if you're connecting to the cloud. So how will your device authenticate itself against cloud that it is a legitimate device, and you basically it is a device which you can trust in, and whatever data that device is sending is authentic, right? So these keys need to be secured. Uh, if you're not securing these keys, and if someone gets access to these keys which are on your device, someone can pretty much impersonate your device and send any and every kind of data on the back end, saying that, okay, and you will not even understand what I mean, why this device is malfunctioning, or whether this device is sending authentic data or not. The next one is data security in transit. So this is basically how you connect your device, the gateway, to the backend, where you need to take care of the in-transit security. So that, I mean, that's something that you should take care of. So against all these problems, I think we have a lot of services and capabilities of AWS ecosystem, IoT ecosystem, which you can use. So Greengrass compatible HSI is basically uh, a library available in Greengrass. If you're implementing your device gateway in Greengrass, then you have access to the HSM module, which can help you put your which can help you secure the authentication keys on your device. And even if your device is hacked, no one can really get access to the key which is on the device. That is an important feature. Second is IoT Defender. So Defender basically helps you put an agent on your device gateway and make you aware of all the security parameters and baseline security policies that you have implemented for hundreds and thousands of devices of yours. It basically eases your security posture of your device fleet. The third is IoT Core. This is an important piece. IoT Core is basically the MQTT broker, a managed MQTT broker, which is scalable to hundreds to thousands to millions of devices. And we just have to integrate your APIs with IoT Core, and you're done. It's that easy. So that's IoT Core. It So why we have put it in security is because it mandates that you have to connect your devices with cloud IoT over TLS. I think we have covered enough in security. We'll go to the next one, which is the connectivity part. I have tried to highlight it, just in case we lose track of the architecture. So connectivity, I mean, again, connectivity is a very simple thing. I mean, everybody understands. We need to make sure we have good internet quality. Internet quality will define the protocol that you want to use to connect to the cloud. Primarily, everybody will be tempted to use HTTP-based protocols to connect to the cloud. But in my opinion, it's not the correct. And I think even if you ask any IoT based provider, you will never see anyone using HTTP for IoT devices. It can be used if your internet is internet speeds are beyond 2G. If it's 3G, 4G, and onwards, you can think of using HTTP based connectivity to the cloud. But otherwise, if you have very inconsistent connectivity and lower network quality, you should always use MQTT, because it's a very optimized protocol. It's a very efficient protocol in terms of power consumption, and it is a very lightweight protocol when it comes to transmission over the TCP channel. Transmission frequency. This is again how frequently you transfer the data to the cloud. If and you should really look at even if you're using if you have a good connectivity, you should always try to transmit data in batches. If your use case allows, some use cases dictate that you have to put data in real time on the cloud. But for some use cases, if the data is not to be uh, you know uh, processed on or acted upon immediately, you should always look at batching your data on the gateway and then sending it, say, hourly or daily, if that is that if your use case permits. Number of devices. This is where, this is something that you will realize when you are dealing with hundreds and thousands of devices, because if you have so many number of devices and they are sending data on a regular basis, the backend infrastructure, which is supporting this data ingestion to the cloud, has to be scalable. It has to be built in such a way that it is able to handle such kind of traffic from hundreds and thousands of devices. It will have a lot of burden from infrastructure standpoint and scalability standpoint. It involves a lot of heavy lifting when it comes to building your own backend infrastructure for supporting cloud ingestion, right? So this is where AWS IoT shines, because AWS IoT really doesn't require any management of servers. This is where cloud based IoT services shine, because they don't really require any kind of infrastructure management. You just pay as you go, and you are able to handle any kind of scale in terms of devices that you can connect. uh, Bidirectional connectivity, this is a very important one. If you have devices, right, you will always think of not only getting the device from the gateway to the cloud, getting the data from the device to the cloud. You will always want some kind of control and command signals flowing back to the device from your cloud, right? You might have some application which is like Mandar mentioned in the previous example, where we were able to shut down the machine from the cloud to the device, right? So there was some kind of control and command signal which got fired. In those cases, you need to have a protocol, the cloud connectivity protocol, which understands, which basically supports bidirectional communication, right? If you are relying on HTTP based transmission for cloud connectivity, you can transmit the data from the device to the cloud, but the reverse might not be possible in all the cases, because all the devices don't necessarily have a static IP which you can address and fire a command from the cloud. So in those cases, you need to look at protocols like MQTT and WebSockets for that matter. They support bidirectional communication, where you can transmit information in any direction, be it it's beside a firewall, or whether it has a static IP or it does not have a static IP, doesn't matter. So for IoT devices, I don't think it makes sense to put static IPs. Usually, the IoT devices are constrained devices, and they are in hundreds and thousands of numbers, where static IPs don't really make sense. This is cloud connectivity. The next one in line is IoT device management and monitoring. So once you have all this, connectivity, your gateway figured out, how do you ensure that your gateway is performing to the optimal, right? And how we are able to monitor those devices. So when I say gateway, it does not mean that you have to have a gateway which is connected to sensors. You can have gateways which are in itself sensors, and you can basically also manage those devices which are end devices and not necessarily gateways. uh, yeah, so governance is important. How do you manage so many devices? If you have few devices, it's simple. I mean, still you will have certain kind of labor induced, right? You will have people who are taking care of multiple devices, their uptime, their health checks, whether what is wrong with those devices. So you need to have a robust governance on top of these devices. And how do you take care of those things? So AWS has a IoT device management offering, where you can pretty much govern all the aspects of the device, starting from health monitoring to tunneling. Tunneling allows you to get into the device from cloud. If you want to figure out some problem in the device, or if you want to say factory reset a device, or if you want to say, for example, change some configuration of the device if the device has malfunctioned, right? It's a very handy tool for most of the customers we have seen. uh, the ease with which you can really remote login into a IoT device from the cloud in a secure manner, allowing you to do anything and everything to solve problems, is really a nightmare that every ONM manager will understand. It basically solves that problem. Then there is OTA, which is firmware updates, right? How do you make sure the new firmware or the patches or the security patches, the firmware updates are reaching your devices in a timely manner, and they are being versioned and kept track of, right? If you have hundreds and thousands of devices, how do you I mean, it's a nightmare to basically understand what version of firmware is installed on what device, right? You need to have a orchestration software available somewhere which will take care of installing these firmware updates on your IoT devices and keeping track of what version is installed on what device, and also allow you facilitate rollback, right? If something goes wrong in a IoT device while you are updating the firmware, it also should understand how to roll back so that the device is not basically bricked. So I can give you an example of iPhones and Androids, right? So they have those firmware updates. You get a lot of updates every now and then. So this is similar to that. I mean, you have to the update process is very crucial, right? If during the update you don't have the power connected or the battery died off, your device will eventually get bricked. It's beyond recover. I mean, you I think those of you who have faced this will relate to this problem. So this is a very critical and important feature that you should take care of while uh, you know uh, defining a roadmap for your uh, IoT implementation. Okay, now we'll cover the analytics piece. I think this is something that I'll not cover much of the data of the analytics. I'll just try to make you understand how analytics can can play an important role, and how you should basically have your data pipelines structured so that your IoT data is reaching the right place and is being processed in the right way, right? So again, I'll not stretch this slide. I think we are already running out of time. I'll just quickly try to summarize this slide. So basically, we have a lot of so from IoT standpoint, we have to consider the data volume and frequency. Uh, so the number of devices that are connecting, the amount of data each device is sending, and what frequency is this is the data getting into the cloud. This will basically help you answer whether you will need some kind of a Kafka or Kinesis as a backbone in your architecture, or whether you can just do away with having a relational database and a database directly getting hits from your IoT devices. So if the volume is more, you definitely need to have a messaging buffer layer in between your database and your end devices, right? uh, Important events. There are cases, there are use cases where you would want to take immediate decisions based on the data that is flowing from the devices on the cloud, right? Say for example, you are monitoring a temperature of a certain component, and you want to basically trigger an alarm immediately as soon as the temperature goes beyond certain threshold. The traditional way to do this is you can just put this event in our database, have some process reading this database and triggering an alarm out of this. But if you're using AWS managed services, you can basically define rules on IoT core, where you can just say, okay, if there is an event which is saying that the temperature has reached or reached a threshold, you can basically trigger an alarm just by writing zero code. I think there is no code required for building such capability on cloud, specifically when you're using cloud based services. Then there is data structure. Again, IoT data, usually the telemetry and sensor data is time series based. Sometimes the data is also a good fitment for NoSQL cases. So it depends on your use cases where your data should reside. Should it directly go in a time series database, whether it should go in a NoSQL database, or whether you want to run analytics in future, right? Then basically you can have ETL or Redshift or ETL in place, which will help you process this data as soon as your data hits the data lake, right? I'll just skip this slide. I think we're running out of time. Machine learning. I think I'll cover the IoT specific use case here. I'll not stretch this slide much. So if you're using Greengrass, right, you will have a very good capability of deploying the machine learning model right into your edge gateway. Right? This is a very important use case and a feature wherein you don't have to rely on the backend where you are running your training, you're building the model, and you are drawing inferences from your machine learning algorithms, right? You can train your model, you can build your model, and you can deploy your model on cloud But once the model is ready, once the model is trained, you can put that trained model directly in green grass, where you can predict, based on the live data that the gateway is receiving, and directly, give predictions and take actions on top of these predictions. So this is a very powerful feature where you can deploy the ML capability right into your edge gateway with minimal, power, consumption or requirements. uh, yeah, and so not all IoT use cases will be text based. There is IoT use cases where you will have audio, video, images flowing into the devices and going into the backend. So for those use cases, it's good to use managed services provided by cloud providers, because it's very hard to build machine learning capabilities around processing of media assets like video, audio, and images. It's very hard to build those models, let alone process these. So it's good to use the capabilities provided by tools like Recognition in this case. Recognition basically is a service provided by AWS, which is totally managed. It has pre-built models which will allow you to do a lot of labeling of the data. So say for example there is a image of a factory, and you want to understand what all components are there in that image. Recognition can pretty much understand what all components are there. It can do object level recognition, and it can give you the name of objects that it has detected in that image, right? Similarly, for videos, it can also understand the motions, in a video. If, say, for example, there is some video-based event that you want to take an action on, and that video-based event is telling you that, okay, something went wrong with this device. Recognition can help you understand that event and take an action based on, whenever that event occurs while it is processing the videos. So this is a very powerful feature. You should always use managed services for media kind of data for machine learning. The other use cases, I think, you can pretty much build your own models. Okay, finally, I think we have covered the architecture. This is pretty much summarizing what we have understood so far from the use cases that we have implemented for multiple customers. What we have seen is, you know uh, so this slide is basically trying to summarize a framework, right? A sort of framework which has worked for multiple customers who are just starting their IoT journey. So uh, you know uh, so starting with an MVP. So MVP is very important because IoT is still, as a technology, it's still in the nation stage, and a lot of businesses are yet to adopt IoT. In that sense, it is very important to take a business buy-in, right? Whether this IoT solution is working or not. In the sense that you need to have a MVP in place, so that you're able to showcase, at least understand what is the sensing technology that will be required for your use case. What is the protocol that is required for your use case? What is the gateway type, whether you will require a ruggedized device or not, whether you will require certain compliance to be met or not. What will be the cloud integration protocol? What will be the cloud connectivity network protocol? Like, will it be 2G, 3G, 4G, whether it will be LoRa? So MVP is a very good start if you are starting with your IoT journey, uh, because the outcome of MVP will directly affect the business readiness to adopt IoT, right? For your higher management to really start off any IoT project, they will need a working model, and MVP can very well serve that model for you to kickstart your IoT journey. Once the MVP is approved and your business is saying, okay, you can go ahead with your IoT project, production readiness is the next thing that you should worry about. Production readiness involves hardening the gateway from hardware and software perspective, from security perspective, having robust process around how do you provision devices in a factory, because once you have the gateway in place, once you have decided that, okay, this is the gateway, this is the technology, this is the hardware, this is the software that will be required to run my gateway, you need to manufacture that gateway en masse, right? And there needs to be some SOP, some kind of process around manufacturing of devices. So you need to devise that strategy, that SOP for your production readiness. The next is device testing. This relates mostly to the compliances that some industries might require for IEC or IP 6567. So there are a lot of testing agencies which help you test your devices against those standards and certify your devices for those standards. Lastly, there is custom PCB design and manufacture. So most of the use cases which are complex in nature, which require specific protocols to be implemented in the gateway, will require a custom PCB design, where we are able to mass produce a device at a very low cost, right? If you go with a industrial PC or industrial gateway, which is available off the shelf in the market, the unit price will be, I mean, if you have a requirement of say 10 pieces, 20 pieces, the unit price will itself be a very cost prohibitive for most of the customers. But if you have long-term plans for adopting IoT, and if you have requirements of hundreds and thousands of devices in future, you should always have a PCB designed so that the economy of scale will help you reduce the cost of manufacturing to a great level, and will help you mass produce it and bring down the unit cost to very minimal, right? Then there is device management and monitoring. I think this I explained in the previous slides. You need to take care of all these things. Uh, I'll not just repeat these points. Dashboard analytics. This is again, there are a lot of capabilities available in the cloud platforms, where you don't have to build your own custom solution sometimes, because if your use case is very simple, like you just want to plot certain graphs and just want to create some alarms, it is available just as a configuration in a lot of cloud providers like AWS. AWS provides QuickSight for your BI analytics of data that is residing in your databases. There is IoT analytics, which is an off-the-shelf drop-in replacement for any and every kind of analytics that you want to do on IoT data, right? If your use cases are, I mean, if your requirements are very constrained, and if your requirements are very specific, I think you can do away. You can just go ahead with ready-made off-the-shelf services, offerings provided by cloud providers. This will help you the time that it will take to build custom solutions, and it will also help you do a faster go-to-market, right? That is, these both aspects will be important. If you have certain specific requirements which require custom solution building, then it should be figured out, and of course a custom solution can be built. But this is a choice, right? You need to evaluate whether all your requirements are fulfilled by ready-made solutions. If yes, it will save a great deal of time, and it will help you go to market faster. The last but not the least is operational support model. Once you have your devices, your IoT, everything sorted out, you have your devices running in production, everything is working fine. You need to have certain policies in place, certain SOPs in place, certain support model in place, which will help you have provide some SLA to the business, right? If some device goes, if some device hardware fails, if some software fails, what is the SOP? You need to provide some kind of a RTO, RPO for the uptime of all the devices. What is the warranty available for each and every devices? If some device fails, how do you really take care of the issue, and how do you fix it? What is the business impact that will have? So you need to have an elaborate support model established. Once you're going in production, and specifically if you have hundreds of devices, you need to have a proper support model built around your IoT platform or solution. I think this is it. I'll wrap this session now. I think I've overshooted by 10-15 minutes. We can directly jump onto the Q&A session. uh, I'll just wrap this session up.
Hi. So, guys, if you have any specific question, you can type it in the chat. We already have one question from Mr. Pritesh. So I will just repeat a question. Many industries works in isolated network that is not connected to external network like internet, and so surely not being able to connect with the cloud. So how can these industries get benefit from
Yes.
industrial IoT? Shoel, do
So
you want to take that?
yeah, so I'll cite an example for that use case, right? So we have had a use case that we have worked on previously. It was more of a asset tracking use case, supply chain use case, right? Where the device was pretty much traveling all the time, and since number of devices was so huge that we cannot have internet availability on each and every device, right? So what we did was we devised a solution where the device itself has limited buffer capacity to store the data that it needs. And whenever it reached specific junctions, right, we used to fetch the data from that device and wipe clean the memory, so that the systems are up to date and the device can again start its journey of collecting the data which is offline, right, which is not connected to the internet. Coming to your use case, if you're saying that I'm assuming that you again, I'm not sure what kind of industry you are talking about. So if the device is stationary and still you don't have internet access, it is pretty fine. I think the same strategy can be worked upon in this use case, where you can use green grass, right? Green grass allows you to be offline from the internet, and also but still provide all the cloud benefits in your industrial setting for all the IoT devices, such that I think if you have internet connectivity every say month or every week or something, you can sync up that data with the cloud and have inferences drawn out of that data. So if there is a cloud, if the cloud is still an option, right, if for you cloud is not an option, then still we can use greengrass, but then the backend solution has to be built in house somewhere. I mean, it will not be a cloud based solution then, but we can still use a lot of cloud features like edge processing provided by greengrass, or all the ML inferences or ML capabilities on the edge gateways. I hope that answers. Yeah, Mandar, you're not audible.
Sorry, I am on mute. Am I audible now?
Yes.
Yeah. Any advantage of using AWS IoT over Azure or any other cloud service provider? I think most of the cloud providers have similar services, and if you find AWS has say IoT core, you will find similar solution on Azure. The only difference is AWS platform is little more mature compared to other platform, but definitely we can choose any good public cloud platform which has a good amount of IoT exposure and services like Azure or Google, and you can use those cloud platforms.
Yeah.
Next, strategy for real-time communication with the device. Yeah,
Yeah, I
Shohel, you.
think yeah, so I think I covered this. We can use MQTT, which is a socket TCP socket based protocol. It pretty much allows you real time communications with the devices. Yeah, I think if you implement that, I think it will help you fetch real time data from the devices.
Yeah. Another question from Mr. Pulin. Can we collect data from different machine and make single report? Yeah, definitely we can collect data from any number of machines and curate it into a single dashboard. So that is very much available, and you can use BI or you can build a custom dashboard as well. The next question is from Mr. Sanjeev. It's cybersecurity part of the industrial IoT architecture platform? Yeah, sure. Can you take that?
Yes. So cyber security, right? It's a very good question. I mean, I've tried to cover, few areas which we can really, help mitigate, like securing the, keys, the private keys which are there on the device, which are very important, uh, and then monitoring all the, all the matrix, all the security matrix or OS matrix from that device. Apart from that, if there is additional need of cybersecurity, I think there are off-the-shelf products available in the market which provide anti-malware, anti-virus capabilities on the device itself, which will help you extensively secure your security baseline on the device. I think we can take this separately, understanding what is the specific cybersecurity use case that you're looking at, and we can definitely, work around a solution around that.
Yeah, I think we'll take one last question from Mr. Santosh. I would like to understand about how device identity involved in industrial IoT can be secure, how devices identity going to manage, and how about communication between these devices can be made secure.
Okay. So, like I said, right, the device identity is essentially a device certificate. Again, it depends on the implementation. But when you go about implementing a IoT solution on AWS, AWS mandates that you need to have a device certificate, which is essentially your X509 certificate, a private key basically, which needs to be there on the device, which needs to be passed on with every request and every information that we share. That has to be passed on to the cloud. So securing this identity is very important, and I think mentioned about capabilities of hardware security modules on the device, provided by hardware providers like Microchip, that is NXP. So these devices are purpose built to secure the identity information of the device. Even if the device is hacked or compromised, you can be rest assured that the identity of that device will never be impersonated, because it cannot be reused by any other device. So that is a way to secure the identity. The other way is how about communication between these devices can be secure. So communication between the devices or with the cloud can be done using TLS 1.2, which is a data in transit encryption protocol. I think that will pretty much help you secure the communication channel.
Yeah, I think we are done with all the questions. We have last question. MQTT will be pops up. So
Right. I think this is a follow-up to the question that was asked initially. Right. So by real-time communication, so there are multiple. I'm not sure what is the question here. I understand
yeah, I
MQTT is
think
pops up.
it's
Uh,
continuation with his earlier question with the real-time
right.
communication with the devices. We can
Correct.
use
So
them.
I think MQTT will, even if MQTT is pub sub, it will allow real-time communication. You can have, topics, MQTT topics, which are assigned to these devices, which can be subscribed by these devices all the time. And if you want to communicate to this device, you just have to publish a message to this device, to this topic, and the device will get the topic because this device is subscribed to that topic, right? And if this device wants to send some data to the cloud, it can again be designated with another topic, which can be a common topic between the devices, and where a subscriber on the cloud will be listening to this topic and receiving the messages. Right, so this is a way that we implement. If the real time is more to do with the web side of things, where your web application is serving the traffic to the end users, there web sockets will help, because you can have web sockets implemented to have bidirectional and real time communication between your web browser and the backend software that you have built. So for web-based real-time communication, WebSockets are the way to go. For IoT device real-time communication to the cloud, MQTT is the way to go. I hope that clears it up.
Okay. I think we are done with the Q&A session as well. And I would like to thank everyone for being patient and joining this webinar with us. We will send you the recording over the registered email, and you can reach out to me anytime over my email if you have any specific queries, or if you want to take things ahead and you want to discuss something.
Thanks, everyone.
Thank you.